I don't know if it's used in everyday life, but it can be used a lot if you have, if you're trying, there's a thing in economics called like a feasibility graph. So if you know that, you can have a certain number of animals on your farm, right? So you're limited by the size of your farm for how many animals you can have. And you know that it costs this much to feed one kind of animal, but then you can sell it at market for this price, right? And then for your other type of animal, it costs a different amount to feed and you can sell it for a different price. And you're trying to figure out what's the best way to maximize your profits. You're going to be looking at where these lines, they're going to be linear equations, you're going to be looking at where they intersect. So you have to be able to find intersection points, and those different intersection points are all going to tell you different things. So that's one place where it's useful. If you want to impress your friends in Europe with the temperature change, at what point are the temperatures in Celsius and Fahrenheit the same? Do you know what it is? It's 40 below. 40 below centigrade and Fahrenheit are the same. So you can tell people. So, when do those temperatures cross? If you know that something is changing by a certain amount, and you know that you can't, like if you've got something where pressure's building up, and it's okay if pressure builds up for a while, but you don't want it to explode, so you need to know where that stopping point is. You're finding intersections of functions. So when you start with linear equations, that's the introduction to finding how to intersect functions, but then you can take those same ideas and apply them to all different kinds of functions and figure out where things are intersecting and what those important points are.
I'm going to show you how to solve by graphing. First, you need to find the points on the lines. That point is 0, 1. And that other point right there on the x-intercept is 2, 0. The other one right there next to it in the green is 1.5, 0. And the one up top is 0, 3. Now that you have all the 4 points marked off, you can write them over here, or you could just go right into the y equals mx plus b equation. So it would be y equals negative 2x plus 3, because 3 is the y-intercept, and which equals b, and negative 2 is the slope. Now with the equation you can find that y is 0.5 and minus 1, and x is positive 5 divided by 6.
The equation is 5x plus 3y equals 7 and y equals 4. First, substitute the 4 into the y value. 3 times 4 equals 12. Then, rewrite the problem so it's 5x plus 12 equals 7. Then, the next step is to subtract 12 on each side. Then, this will get you to 5x equals negative 5. Then, you divide 5 on each side to get x by itself. The answer will be negative 1.
Solving by elimination. So the equation is 2x plus y equals 12. Negative 5x minus y equals negative 33. So what we're going to do is we're going to add these two equations together. And as you can see, positive y plus negative y cancel, and so you're left with 0. And now we're going to add 2x and negative 5, which equals 3x, And then we're going to add the two numbers on the other side of the equal sign. And 12 plus negative 33 is negative 21. Now we're going to divide both sides by negative 3 so we can single out the variable. This allows us to solve for x. And as you can see here, negative 21 divided by negative 3 is 7. So x equals 7. Now we're going to plug this back into the equation. And plug the x variable back into one of the two equations. You get to pick which equation. So I'm going to pick the second one, which gives us negative 5 times 7, because remember the 7 substitutes for the x value, minus y equals negative 33. Multiply negative 5 and 7, and we'll have negative 35. Minus y equals negative 33. Now we have to get the variable by itself again. So we're going to add 35 to both sides. So you get negative 35 plus 35 minus y equals negative 33 plus 35. And so the 35s will cancel, which gives us y by itself. And negative 33 plus 35 is 2. So y equals 2. 7, comma 2. Remember x and y in parentheses. And there's your ordered pair, 7, 2. And that is how to solve using elimination.